My name is Daniel Hinojosa. I'm going to be talking to you about Guava 2015 edition. I keep doing this every year, and I'm kind of in a weird situation right now because I don't know if people actively use Guava and just want to see new stuff, or have the majority of people never seen Guava in the first place. So if you don't mind doing me this favor and answer this poll, how many of you actively use Guava now? Okay, and how many of you never have used it or seen it? Okay, so still a majority on here. So yeah, I don't, maybe perhaps I should start thinking about presentations about some of the other things in Guava that you may not have seen for those who already know Guava. But this is more of an introductory one. So let me just go ahead and warn you, if this is great for anyone who's never seen Guava, but if you've played with Guava before and know most of it, I'm afraid you could get bored, and it's not going to hurt my feelings if you go on and take a look at other presentations. But this is a presentation for those who have not seen Guava in the past and would like an introductory presentation on it. And probably in the future, in the very short future, maybe I'll have a Guava for those who use it and would like to know some of the more new stuff. All right, so making Java Bearable with Guava 2015 edition, I have very few items. So here's the problem. I'd like to put in new items, but all the basic stuff is actually pretty good. And I don't want to remove it because for those who have never seen Guava before, they need to see all the introductory stuff up hand. Pardon me while I move furniture. All right, so this right here is a restaurant out on Dulles Airport, and I thought, wow, amazing. So that should actually be my title slide. Guava in Java, it's a little nook. If you go to Dulles, and if you particularly fly on Southwest Airlines, it's right across the way from the baggage claim there at Dulles. So who is this for? This is for any Java developer who's not familiar with Guava. And this is particularly for those who have to use Java by company rule or by company fiat. In that you're not allowed to use Groovy, you're not allowed to use Scala, you're not allowed to use Clojure or JRuby or any other languages like that. This has been a remedy for Java, which had been stale for many years up until Java 7. Java 7 has some nice utilities that come with it. Java 8 definitely has lambdas now, which makes things a little less painful. So this was meant as a remedy, but it also turned into something where it has nice collection libraries, which I'll introduce you to. So it's a must-have library. If you're using Java 7 or below, I'm not a pushy person, but if you're using those particular versions, I usually push the notion that Guava has to be one of those libraries that you have to have on every project at all times. Before Java 7, I usually also say you have to use Jota time at all times. Those two libraries are a must-have pre-Java 7. As of Java 8, Guava is still must-have. You do not need Jota time anymore because of the new datetime API that comes with Java 8. That scream wasn't very manly, was it? All right, so 2015 edition. What's new? Actually, some of this stayed around from the 2014 edition. Integration with Java 8. What's new? How's that going to change Guava? An enhanced loading cache presentation. I'll get extremely nerdy on some of these. Concurrency, I'll add stopwatch, which I think is a really neat utility. What went away is optional. Now, I don't know if you know this, in Java 7, I think it was Java 7, optional came out. We use that a lot in functional programming. Optional is the object that states whether I have an answer, and if so, here it is, or I don't have an answer. There was an optional implementation in Guava, but as of Java 7, they have that, so there's no need for that in Guava. Splitters and joiners, the ability to split strings nicely and then join them back together. That used to be a pain in previous versions of Java, but not anymore, so that has been remedied. So you can use the Guava stuff, but Java has it now. So where can you get the code? All the code I have here is at github.com. /my name, D Hinojosa, /using Guava. So all this code, all my slides are backed up by code. They're all JUnit tests. Run them, see how they work, and you're more than welcome to add to it. It's a public repository, so have at it. All right, so what is it? It's an indispensable set of utilities. It's additional and immutable collections built upon the JDK. It's open source, and I'm going to put an asterisk there. It's open source in that you could read the source, but if you try to contribute, it's most likely they're going to deny you any patches anyway. It's kind of a remote castle in that no one really contributes to it. They like to add to their own. They like to have complete control of it. Not really in the spirit of open source, so it's open source with a little caveat. Okay? Fully generic collections, unlike Apache Commons, so it makes use of generics. It's continually growing. If you take a look at the API, there's an @beta throughout the API. All of that is considered somewhat experimental. I really love Guava because everything is thoroughly tested. I like software that is thoroughly tested that I can use, that I know they put a good effort forward, and I know they put such a good effort forward that actually inside Google, they make this library mandatory for all Java projects that they develop in-house. This allows you to embrace the dry principle even more. If you don't know what the dry principle is, it means don't repeat yourself. So if you want to get rid of a lot of code duplication, this is the library for you. So I have this Eclipse here because Guava has been overshadowed by a few things, particularly Java 8, but it's there as a helper library. It's not meant to overtake what Java has, but merely just complement it. So let's get started with Guava Collections. Right here I have a bimap. Let me get away from this microphone. I have a bimap. Now a bimap is just like any other map. You have a key and value along with it, and here I have an English-Spanish map. Okay, so this is my English-Spanish dictionary implementation that I have here. So with this, I am going to create an English-Spanish map, and I'm going to put book, libro, cloud nube, escuela, and computer ordenador. And just like any other map, if you try to get a computer out of it, you get ordenador. Okay, pretty nice. If you try to put fill with llenar, that works okay. But if I try to put feed with llenar, the values are the same. And so you can't do this with a bimap. And so because of that, you'll end up with an illegal argument exception if you try to do that at runtime. I could force put, but in essence, this is going to be replacing the key value that is the fill and llenar. So fill will no longer be in this particular map. So as you can see here, there's feed, but no longer any fill. Now, why is this? Well, because what I can do, if you take a look at that middle line up here, is that I can do an inverse on this particular map. So given this English-Spanish map, I can call inverse on it, and what I'm going to get in return is a reference to another map. Now, Google Collections tends to use a lot of views with their collections. In other words, you have a certain view of the data. So in all likelihood, there's like 2 maps with this particular bimap that's storing. And depending on what reference you have, you're looking at the data in a certain way. And there's like a little synchronization going on there that if you add one to one map, it's flipped and you're seeing it through another map. So that's what we get here with the inverse. So here's the thing. What I get from inverse is a reference, but it's flipped. And so I'll have a Spanish-English map. So if I call Spanish-English map to string, what I see are the Spanish words and then the English words. Okay? Fair enough? This is what a bimap is. I'm able to flip this. But here's the interesting thing. If I have football and soccer, and I put that on the Spanish side, the Spanish-English side, obviously you'll see football is equal to soccer. But without calling inverse again, remember all I have to do is just keep these references. Without having to call inverse again, and I call English-Spanish map to string, there's an entry right here that's surprising, all right? So soccer, football appears on the other side, okay? So it's this kind of shared state with the map. And all I have to do is flip it, and if I need translation or any other kind of collection, then I can do so with this particular bimap. So the key ingredient to this bimap is this inverse method, okay? Now, there's a multimap. That's another collection. Oh, by the way, I started using Scala a lot more. So Scala is my primary language now. And I still use Guava for these collections. You can't find them anywhere else. So these are going to stay with you no matter what language you use. So I find these extremely valuable. Multimap. This one is ArrayList multimap. So you can have this multimap. There are different flavors of multimap. You could have it backed up by a linked list, a tree, a sorted set, whatever you want. In this case, I'm just choosing a array list in this case. All right. So I'm hearing a modem. Is that right? I went back in time to 1995. All right, so multimap. All right, any Dallas Cowboys fans here? Anybody? Anybody? Yikes, wrong crowd. All right, I guess I'm the only. All right, so I'm a Dallas Cowboys fan. Boo. All right, so let's say I have a multimap here, and I just want to calculate some sports data, and I have Dallas Cowboys, where all the Super Bowl wins that they have 5 wins. 72, 78, 93, 94, and 96. People like to say Cowboys fans always like to talk about their history because that's all they got. So that's all I got. My history ends at 1996 as a sports fan. Pittsburgh Steelers has the most, 75, 76, 79, 80, 2006, and 2009. Now you can kind of see the theme of the multi-map here. Steven? No, I'm just kidding. No, go ahead. So on this one, you could kind of sense a theme going on here. I could have as many values as I want per one key. Okay? So Dallas Cowboys, I could have 72, 78. So what you're seeing here is it's going to be backed up by a map with an array list as the value. But it does all this clean stuff for you, so I don't have to think too much about it. Okay? So this is all built on that trust. I trust Guava to do the right thing. That's why I go for this kind of thing. So given a Super Bowl map, Dallas Cowboys.size, that will return 5. If I call Super Bowl map.get Pittsburgh Steelers size, that will return 6. And here's the thing. Nowhere in here did I add Buffalo Bills. I've never given this presentation in Buffalo. So I'm sure I'd break some hearts here. But if I call get Buffalo Bills dot size, that returns 0. But again, I never explicitly added it here. It does all that extra stuff for me. Okay, so that's a really nice thing to have. Now here's a multiset, also called a bag. Okay, now this one is just a nice little set that actually just keeps count for you. That's all really it does. And so I have a multiset of strings, and I have different flavors. Enum, hash, immutable, multiset, linked hash, so whatever flavor I want on the back end. And let's talk about soccer. Actually, I think I still need to update this, right? No, I have Germany coming up. They won the last one. All right, so Brazil I have 5 times. Italy I have 4 times. So I'm adding Brazil, again, 5 times. I'm adding Italy 4 times manually. So what I'm going to get as a 2-string representation from this particular bag is I am getting Brazil times 5 and Italy times 4. Okay? Now, I can add things explicitly. I think that is incorrect. I think Germany is now at 4. Any soccer fans here? Okay, 1. Wow, that was more than the Dallas Cowboys fans. All right. So I can explicitly say Germany 4, and that would show up as Germany times 4. Okay? I can call the count, but just like the previous collection I had with the multimap, that if I call count on United States, I get 0, even though I didn't explicitly state that the United States was in there. Okay? So these collections actually come in very handy. And here's the thing. So how do these collections play a role in the world of Java 8? So given this now, let's say I want to print line each of the items within this World Cup Championships. So this has already been engineered and ready to be used with Java 8. Everything was designed really well. So in this case, if I have a World Cup Championships, how many of you started using Java 8 and some of the lambdas? Okay, still a small fraction. So if you've never seen this before, this is how you can do this functional style programming in Java. So given a World Cup Championships, I'm going to call a stream. This is going to return to me a stream object that I can do filter, flat map, map, for each, and different things like that. So in this case here, I'm going to take that stream object and I'm going to call for each on it. And for every element that's in there, in line, I'm going to call system.out.println. Okay, that's what's seen up there. That's all Java 8 and how it works with Guava. The second one is just a shorter version of that. Since I only have one thing coming in, T, and that's directly being fed into system.out.println, I can do a method reference. That's what that's called there, and it's just a shorter version of that. I can just call system.out::println. All it's going to do is just take that one element and drop it into system.out.println. So I can use streams to do a for each, or I could do a map. So let's say that for my World Cup Championships that I have here, where I have Brazil, Italy, and Germany, for example. And let's say I want to capture a stream. So given this World Cup Championships, I'm going to capture this stream. And again, once I capture that stream, I could do filter, I could do for each, flat map, or whatever it is I like to do. And I'm going to take this map, I'm going to grab the S, and what I'd like to do is for every item that is within this multiset, I want to call it Team Italy, Team Germany, Team United States. The thing that you have to do, though, at this point right here, it's still a stream object. So in Java 8, what you have to do is you have to recollect it into what's called a collector. You can make your own, but it's a little bit of a PETA. What you could do is you can actually call collectors to collection and bring it back as a hash multiset. Okay? This collectors to collection allows you to plug in whatever type of collection you want to bring it back in as. Ready to go. So Guava works fine if you plan to use Java 8 lambdas. All right. Immutability versus unmodifiability. Java has unmodifiability. So here's the unmodifiable set from the JDK. So given a hash set, I'm going to add a few items. Here I have an unmodifiable set by calling collections.unmodifiableSet. I feed that int set into it, and now effectively it's unmodifiable. And actually the engineers behind this were actually really smart because they didn't lead you to the impression that these collections are immutable. Immutable collections are, you put something in it, you actually get a copy back, and the original still stays the same. Whereas in this case, it's really a facade. You're looking at a little facade. You think that you're not allowed to change it, but in actuality you can. So if you have that original reference, you can subversively add 10 to that. And for the person holding the unmodifiable set reference, all of a sudden, for something that just had 4, 5, 6, and 7, all of a sudden there's a little mysterious 10 going on there. Okay? That's the difference between immutability and modifiability. Unmodifiability is on the JDK, immutability is not. So therefore, Guava, being the good citizens they are, so again, you can't modify the collection, but I can if I have the original reference. Guava contains factories to actually create immutable collections. So you can actually have some immutable collections that you can use. Map, multiset, multimap, sorted set, sorted map, list set. So not only for the JDK stuff, but also for the Guava stuff that we just learned, like multimap and multiset. Okay? So now, how do we do this? So the recipe is this. Immutable, that's not generics right here, it's just you replace that name with whatever. So if I want an immutable set, I'll call it immutable set. If I want an immutable map, I'll call it immutable map.of and add all these elements. Okay? So given an immutability with list, for example, if I want an immutable list, I can call immutable list of, and it uses var args here, so 4, 4, 5, 6, 7. Okay? And I could go on forever. Okay? So this is an immutable integer list. If I try to make any modification to it, I'll get, I believe that one I get a copy from. If I have an immutable set, that's how I create it. If I wanted to create an immutable map, by the way, this is a really nice, quick, and easy way to create a map. What I can't stand about Java is, like when you create an array list, you have to do array list, and then once you have that, you do add. Whereas this one, it has a lot of really neat decorations to do a quick inline of certain collections, and it makes that a little bit easier. So given this one right here, this is an immutable map of a key value pair. So New Mexico, Santa Fe, Texas, Austin, Arizona, and Phoenix. Okay, and that's a map. And of course, if I do a toString here, it shows that I essentially created that map. Nice, quickly, easily, and all in one line. Here's a bimap. Works out really well. And here's a multimap. But anything that is labeled a map has a problem. The problem is that it only allows up to 5 items. The reason that's a problem is because Java does not have tuples. So you could only go so far. So all that information I had earlier, cut out. I mean, I could only go up to 5 elements. So what's the solution? So in this case here, if I try to do something like that, I'll get a compile time exception. The signature's wrong, it's not going to be able to work. So the solution is to bring out a builder, and this is just your all-loving builder pattern that you know and love. And so given this now, if I want an immutable set, I'll use a builder to add elements, or if there's something funky I wish to do and how I construct this particular set, again, I'll go with the builder. So if I have an immutable list that I want to create, I have a few methods like add all. I have add. And then when I'm done constructing, I just call build at the end of it, and I'll get a int list back. If I wanted a set, very easy, immutable set.builder, add all. When I'm done, I just click build. For a quick map, I can do immutable map builder. I could do a put whatever elements I want in it all in one line, and when I'm done, I hit build. Okay? So life's too short for a lot of add methods. You like to just get things done in one line, and this is the utility to do it. Here's an immutable bimap. Okay? Again, with a builder. So coming back to my Super Bowl multimap, if I want to put in a bunch of elements, and if I do a toString, this is what it looks like. So Dallas Cowboys with a list of all the years they won, and Pittsburgh Steelers. By the way, I did this presentation in Seattle. They got angry at me about that one. I don't know if you remember that one, where they said the ref supposedly gave it to them, gave it to the Seattle Seahawks. All right. All right. So predicates and functions. Now, long before Java 8 came around, what the folks at Guava attempted to do was they said they didn't want to call it a functional language, like they weren't trying to make Java a functional language. They wanted to make a few things easier with a predicate and function to do things kind of in a functional way, but again, they were just really careful not to say that this was a function, this is going to turn Java into a functional language. But this is where I fell in love with what would be functional programming in my life. So, and maybe it'll be the same for you if you've never used Guava before, but this was my gateway drug. I started using these predicates and functions, and all of a sudden my swaths of code started to disappear because I was using all these wonderful functions and predicates. And from there on, I was taking a look at my code. I'm like, wow, I could really do a lot of great things with this. This kind of looks like what I read about Scala. So I started reading a little bit more about Scala, and I really became involved with Scala, although there was a huge learning curve with Scala. It kind of had everything that Guava plus Java had, so in my life took a separate direction with this. I don't know what kind of direction this will, maybe this will just stay as a utility and you'll just stay with Java throughout, but I ended up loving what predicates and functions can do for me. So let me just start off with predicates. So here's a predicate. Predicate of type integer, this is a parameterized type, is odd, and this is a reference to a predicate, which is an interface, and I'm going to create a brand new predicate anonymously of type integer. And the only thing that I have to implement is this apply. Okay? It's a funny thing about apply. If you end up ever learning Scala, it's kind of weird. They end up using the same kind of idea here. All right, so this apply here is that we're going to be bringing in an integer, and given that input, I'm going to decide whether this is true or false. So a predicate is like a function, but a predicate will only return a Boolean. Okay? And then we take this predicate and use it wherever we need to. So given this particular integer, I am going to decide whether this is going to be an odd number or an even number. Now, once I have that, I can use this inside any of the collections that is either on the JDK or in Guava. So what I'm going to do is I can call either collections2 or lists or sets or any one of the nice utilities that come with Guava. And in this case here, I could call filter. So if I want to filter this list, 1, 5, 6, 8, 9, 10, blah, 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 I can plug in this, sorry about that, rewind. I could take this unfiltered collection, plug it in here, and take this predicate and plug it into here, okay? It's a little bit more modular. It's not as imperative as you would do otherwise. Plus, here's the thing about this filtering. I could take a look back at some of my 2000, 2001 code, or even earlier than that, and in order to get things out of a list, and I think some of you still have this in your code base, where you extract that iterator, and you take that iterator and you accidentally remove something from the original list, and you get that, what is it called, concurrent modification exception? Any of you still see those once in a while, just because you're trying to, maintain older code? So none of this happens here. All of that, this is a higher level abstraction. You don't deal in trying to get the iterator and trying to remove things out of here. And then the other thing I like about it is I actually get a copy of it. So given this unfiltered list, I actually get a copy in return of every number that is odd. So if I call unfiltered toString, again, this number stays the same, but what I get in return is a copy. But no more fiddling with iterators, no more making mistakes with it, no more concurrent modification exceptions that pop up now and then, okay? A lot cleaner way to do something like this. Now, here's a little interesting side effect. Every time I poll the audience on this, some people are like, ooh, that's interesting. But there are other people that's like, I don't like this at all. So given this right here, I have filter.add23. Now think about that for a bit. I'm taking the copy, the filtered copy, and I'm adding 23 to it. And it allows you to do that. Here's the thing. Now if you inspect what is inside of unfiltered, automatically, there's a 23 that just appeared there. Now, I don't know how you feel about that. I'm kind of wavy on this. At first I thought, wow, that's cool. Now it's just like, that's kind of scary. So I'll let you decide what you think about that. Okay? All right, so the rule on Java 8 lambdas is a Java 8 lambda, a functional interface, is any interface that contains only one abstract method. These are the rules here. And a functional interface may contain one or more default methods or static methods. And because a functional interface contains only one abstract method, you could omit the name of that method when you implement it. So that's the what's called a functional interface definition. And if that table wasn't in the way, this one would tell you that if this does not include things that you override. So I don't know if you know this, but interfaces only have one super class, and that's Java Lang object. So it doesn't count equals hash code. What was the other one? ToString. What is that third one? All right. Now, if you don't know what a default method is, this is new in Java 8. I know I just talked about it here, and you're probably wondering, what the heck is that? All right, so here's a default method. This is just an aside. If I have a abstract get first name and get last name for this interface human, I can create a concrete default method within here that uses the elements from within that interface. So if you didn't know what a default method was, that's what that is. Okay? All right. Now, so thinking back about the predicate, here's the actual definition from the Guava source code. Public interface predicate, I have an apply, and there's an equals, but that's an override. Now, because there's only one, again, they designed this really well. It's almost a nice coincidence that this was automatically going to work nicely with Java 8. So given this array list, I can do a filter now, and I can use the Java 8 style predicate. So given this input, and if this input doesn't return 0, it works just as fine. Okay? So I could actually use lambdas along with Guava. Functions. So this is a function. This type here is for the type that's coming in. This type here is for the type that's going out. So I have a function here called doubleIt, which is going to take that integer and multiply it by 2. So this integer is going to come in. The name is from, so I'm going to take that from and multiply it by 2 and spit out the integer. Okay? Now, what do I do with this? Well, one of the things I could do is transform a list. So given an array list of 1, 5, 6, 8, 9, etc., what I can do is call either lists or collections2 and call transform on it. Give it the original list and give it the function. Okay, and what I'll get back from here is the manipulated list. Again, I have a copy of that. Okay, now take a look. Functions has one abstract method. The override does not count. You can imagine to start doing giraffes. All right, so given this array list, what can I do? Take a look here. Okay, all one-liners. Works great with Java 8. So those are functions, and those are predicates, and those are actually used within the API as well. So utilities. Let's talk about some of the utilities within Guava. Thinking about something real quick. All right. So utilities. The rule is add an S for the utility that you need. It's kind of like Apache Commons that has a lot of utilities that are going to be beneficial for you. And all you have to do is you're typing along and you say, you know what, I need something for Boolean. Let's say I'm just making something up. Add an S to it, look it up. So you go to the Booleans class, take a look at what kind of utilities there are, and you're going to find a large amount of different utilities in there. Okay? You don't have to reinvent the wheel. So Booleans, longs, ints, floats, blah, 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 all the way to functions, bytes. There is actually some more with a later version. I probably need to update this list. But there are quite a few. There are funnels, a lot of different objects that you can use. Okay? So let's go through some. Objects. So instead of doing if a, when you do those null checks, and it's always a pain to do all those, just do objects.equal. Problem solved. So instead of something like this for your equals, you could shave down quite a bit of that down using objects equal. Okay? Save a lot of time that way. Now, here's the thing. Something new came out in Java 7 that I'm not sure a lot of people are aware of. And that's misspelled here. It's called objects, and that is inside of the JDK called java.util.objects. And it has a lot of really neat features like this. So check out the implementations. It's almost like they copied code, kind of like what I used to do in college. Where it's, so here's the Guava implementation, where you have a static Boolean equals, bring in an object, two objects, and here's the logic behind it. So I'm wondering if the JDK people were like, wow, that Guava implementation's right on the money. But that way people don't think I plagiarized it. I'm just going to add a parentheses around that. All right. So what other good things does Java 7 have? So I don't know if you know this. Take a look at Java util objects and make use of these. Okay. Equals, deep equals, hash code. You can actually create hash codes with this utility. Again, this has nothing to do with Guava. This is the pure Java one. Require null is null, not null, require not null. So you have a lot going on with Java 7's objects. So which should you use? I would say go to the Java one. Again, Guava's not trying to overthrow Java. It's just merely trying to help it. So if the JDK has it, I would go with that one and try to keep your application as purely Java as possible and use Guava only when you need to. Now there's a new one called MoreObjects that you can take a look inside Guava. It's the same as objects, but it only contains the things that are inside of Guava but not in Java 8. So if you are using Java 8, use MoreObjects. If you're using Java 7, just use the plain objects. So let's take a look at some other utilities. Lists. If I want to create a new array list, I love that one. List, new array list. I know you have arrays.asList in Java, but if you want to do something specific, actually, and also when you do an arrays as list, you get some kind of little funky class with it. It's not anything that you're used to. It's not an array list or anything like that. It's kind of this weird object. So even though there's arrays as list, I'd rather use the Guava one instead. List, new array list, new linked list, list reverse, list transform. Again, you use that function within here, so you can just transform a list if you need to. For maps, I can instantly create a new hash map, a new enum map, a new linked hash map, concurrent map, or tree map. And just right away, with one line, create these collections, okay? Very much like what the Groovy, Scala, and Ruby programmers have had for years. You can kind of have that now too, where you can just create collections on the fly in one line. So maps, this is where it gets interesting. I can calculate the map difference. I can filter the entries based on a predicate. I could filter the keys, filter the values. I could transform the map given a function, and I could transform the values given a function. This is going to have a lot of great implications on your code because you're going to do a lot of things that would used to be tons of lines, and now you have short amounts of lines because all you have to do is just plug in a function. And this is going to get you started into thinking functionally using some of these utilities. So let's take this example right here. Let's say I have two state capitals. I have state caps on the first one, Tallahassee, Santa Fe, Trenton, Olympia, and Albany. State caps 2, I have Tallahassee, Raleigh, and Bismarck. Now, what I'm going to do with that is I'm going to call maps.difference, and I'm going to plug in these two maps. What I'm going to get in return is I'm going to get a map difference object out of this, and now I could ask things like, which one are the entries only on the left that are unique? And that'll be 4. The only one that's shared here is Tallahassee. And how much are unique on the entries on the right? Obviously Raleigh and Bismarck. I could also ask from this object which entries are in common. Well, there's only one that's in common, and that's going to be Tallahassee. Now, every time I do this presentation, I always ask, imagine doing this in plain Java. This is going to take you a while. Okay, so these utilities are going to save you enormous amounts of time. So given this one, let's take the state caps. I think this is a very interesting example. So given these state capitals, I am going to go to predicates with an S. So predicates has this utility class as well, and I can go there and see what kind of predicates are in there. Now take a look at this one. Let's say I want to go through this map and I want to filter everything in the values. So in other words, generate for me a new map and filter out the values by a regular expression. Okay? And again, imagine doing this in Java. This is going to take you a while. But with this one, all I have to do is think about this functionally. Given a map, given a predicate, take the state caps, use filter values, and plug in the predicate within there. The size I'll get in return is 3, because taking away all these states with new in front of it, that just leaves, wait, why is it 3? Florida and Washington. Huh? Oh, contains pattern, new, Florida. Yeah, but why do I have 3? Oh, that's right. I'm filtering the new, not, for some reason I was thinking I was like excluding the new. Why's my slide wrong? No, that's right. Okay. Thank you, everybody. All right, iterables. So anything that I can extract an iterator out of. I can concatenate. I can ask whether they're equal. I could cycle through it, kind of an interesting one. And I could filter by class. Using these iterables, again, I could filter, partition, transform. I could try to find something based on a predicate. All right, so here's the cycle, kind of an interesting one. So an array list is something iterable I can extract an iterator out of. So what I could do is I could call iterables.cycle, provide it with this list. And now once I extract that iterator from this particular iterable, every time I call next, so even given a size of 5, if I iterate over this 1,000 times, it's going to go 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay? In case you ever need a cycle. Here's partition. Comes in handy. So if I have a list and I want to divide it all by 2, I just call iterables.partition, and that will do it all by 2. Or I could pad it. So if there's some extra space remaining, it'll just pad it with null. Strings. So here's some neat strings utilities. Strings is null or empty. Null to empty. So given a string, anything that is a null will end up as an empty string. So again, you could design all these, but all these are already pre-done for you. You could pad at the end. So things like account numbers, for example. Or you could pad at the start. Or you could repeat a string any multiple number of times. One of the interesting ones is preconditions. Now, if you take a look at your source code for the projects that you're working on, you're going to notice that you may not have such a standard way that you deal with preconditions. So they have a little precondition library, and you could apply as a standard to your own code base. So if you want to check for things that are not null, so given this grade that comes in here, is it null or is it not null? If it's not null, this will throw a null pointer exception for you. So they have standards on what happens if things are null and how you handle them. If you want to check on the state of it, then, well, not the state, but you want to check the argument that's coming in. If the grade is greater than 0 or less than 101, even though that argument exists, that's not the kind of argument I want. So this will throw a legal argument exception. Okay, so it has a standard way of dealing with preconditions. State. So let's say the internal state is incorrect. Again, because you don't want to ruin what is inside of your object. So you want to be as defensive as you can by doing these checks. So if someone tries to call get highest grade from this object, and the grades are not set, or there are no grades entered, then you'll get an illegal state exception. Okay? You actually have to put the positive in here, but if this positive is not met, then you'll get the exception thrown out of it. Okay? There's a new one here, stopwatch. I started using this one recently. I just discovered it recently. I like this one. So sometimes you want to check on the performance of your code. And typically what we do is we capture the time, run our code, and then do the math afterwards. So it's a nice little wrapper. You have stopwatch, create started, do something expensive, and then you can ask, give it to me in milliseconds or nanoseconds. It's a wrapper over nano time, so works out very well. Okay, so if you want to test your stuff, there's a stopwatch there. Okay, so the moral of the story is with all these utilities, if it feels like someone else has already developed it, look it up. Okay, don't try to reinvent the wheel. Now, for LoadCache, a LoadCache is essentially a cache that uses a map. It's a concurrent map, and you could program it to have automatic loading onto this map. It's a least recently used eviction of entries. You can use weak or soft references. So depending on that reference, when the garbage collection comes by, if it's weak, it will automatically be recollected by the garbage collector. If it's soft and you still have plenty of memory, it'll stick around. Otherwise, it will be reclaimed by the garbage collection. You could evict entry. So again, this is a map, just like any other map, but with a lot of really neat features with it. And what's really going on is, it's not really even a map. There are tiny little maps going on. Okay, so a lot of calculation that you wouldn't want to do. This is in case you want to cache on the single JVM and you don't want to use a very expensive caching solution. You just want a very simple cache. You can evict by expiration, since last read or last written. You can create your own eviction listener. Behind the scenes, here's the great thing about it. It does all these maintenance things on a separate thread, and it does it over time. Okay? So you don't have to think about this stuff. This is that higher level stuff that I enjoy about Guava. I never have to think about things like that. And if I ever want to grab statistics, I could just load up those statistics and see what I have. So how do you create this loading cache? So I start off with Cache Builder. I create a new builder on it, and I start setting a few things. How many threads am I going to or are going to be used for this particular loading cache? This needs to be known up front, just so it could be optimized when the time comes for it to be read or written to. Here is the build. So this is a formula that I use to automatically calculate. So in this case, this is a really simple example. If I give it an integer, I'm going to go to sleep for 5 seconds. And right after that, I'm going to return a big integer of the same value multiplied by 500. Okay? So let's take that for example. Again, I'm going to give it an integer, fall asleep for 5 seconds, and then wrap it up in another big integer and multiply it by 500. So that's my example here. So this means that every time I load something via key, the value will have this particular value. So let's say I call map get 4. And then there's that table again. I should do a rockstar thing, right? Some people always say, yeah, oh, thank you very much. All right, thank you, sir. Of course, you robbed me of my rockstar experience. Yeah. All right. So, given this map get, so I'm going to get the key 4, but it doesn't exist yet. And this is a cache. So if I call get 4, then what will happen is I will get a big integer 2000, because 4 times 500 is 2000. But it's going to take slightly over 5 seconds, because this computation took place. Okay? But the next time I do it, I get an immediate response, because it's been cached. Okay? So that's the idea behind this. It's a very simple cache that you can use. Actually, it's probably one of the most valuable things that you find in Guava. Okay? I can specify the maximum size, behind the scenes, again, all this happens behind the scenes. If it's getting closer to 1,000, then the cache is going to start evicting entries based on last recently used. I could expire after a few seconds. So let's say I wrote to this particular cache. After 5 seconds, that will be expired and will be garbage collected. I could expire after a certain access. So if it has not been seen in the last 5 seconds, go ahead and reclaim that. Provide an initial capacity. Here's the formula here. I'm going to provide the copy to the slides just so you have this for reference. I was really curious about this, so this isn't even on the documentation. I had to really dig into the API to figure this out. So again, sets a minimum number of hash tables. So this is why that initial capacity is important. Sets a minimum size of hash tables that back up the cache. So this cache on the back end has a bunch of tiny little tables that provide everything you need. So the number of hash table segments is the closest power of 2 of the concurrency. So if you set it to 4, you'll have 4 hash table segments. If you set it to 20, you'll have 32. Okay. The size of each segment will be the concurrency level. So all that plays a role. So the size of each segment will likely be 4, and the initial capacity will be rounded to the next power of 2. So overestimating and underestimating will affect performance, so you would have to think about it. But you're going to gain the benefit from it. I can specify weak keys. The keys are weak, so next time the garbage collection comes around, if it's specified as a weak key, that entry will be garbage collected. I can specify weak values. I can specify soft values. They prefer you use weak values instead, but choice is yours. Again, you'll have to think about which ones you want to use. And here's my removal listener, and I think most of us know how listeners work. You just implement the listener, and every time an entry is removed from this cache, then this onRemoval method will be called as a callback, and you can report it or do whatever you wish to with it. Once I establish that, I just plug that in as my removal listener, and we're good to go. Now, what am I going to get? As part of the listener, you're going to get this, let's see, where are you? This removal notification. And you can bring up the cause. So every time something's removed, you can ask, was it explicitly removed because someone made it so by calling invalidate? Was it replaced? Was it collected? Was it because of a size constraint issue? Or was it because it expired because we haven't written or accessed it in the last 5 seconds? Okay? So you get a lot of good stuff with this. If you need statistics, call record stats, and this enables statistics to be recorded. I know this is kind of a mouthful here. I'll only choose a few of them. You can ask for the eviction count. You could ask what the request count was. You could ask what the hit rate was, which is the hit count divided by the request count. What is the load count? So you have a lot of good information. So if you want to see how your cache is performing, again, just record those stats, and you get to see what's going on. Again, you can remove entries by either calling invalidate all with certain keys, or just call invalidate all. All right. I'm going to get even more nerdy. You ready for more nerdy excitement with Guava? Futures. I need lasers out of my fingers to do that. All right. Futures and concurrency. So we start our tale with java.util.concurrent. And our java.util.concurrent contains an executor which manages threading tasks for us. And that contains also an executor service that takes a runnable or a callable. So, runnable, I think we all know since the early days of Java, public void run. Callable is public void call, but with an argument. Okay? And those are going to be typically asynchronous tasks that will be done on another thread. Here's the executor. This is the basis of everything. You have an execute and you give it a runnable command. There's an executor service that's a sub-interface of that executor. It has the ability to track futures for us. And services can be started up or shut down. But likely we'll use the executors to create an executor service of our own. So here's a snippet of what that API looks like. All right. So what is a future? Now, some of you, I'm sure you know futures very well, but I think for the most of you, probably never heard the term before, or you kind of heard it in passing. So let me distill what a future is. You're going to calculate an extremely complex formula for me. So he's going to calculate what 600 plus 300 is. So here's my supercomputer. So what I'm going to do is I'm going to create an asynchronous task, and I'm going to say calculate 600 plus 300, and I'm going to say do it. I'm going to wrap it up in a callable or runnable and say, okay, do it. And what I'm going to get in return from this is I'm going to get this future reference. So I'm expecting, so this is future of type T. So I'm expecting something within there. So I'm expecting a future of an int. So while he's calculating that, I'm holding on to this reference. And what I'm going to be doing is I'm going to be like that annoying kid on a road trip. Are you done yet? Are you done yet? Are you done yet? Are you done yet? So he's calculating this, and I'm asking, are you done yet? Are you done yet? Are you done yet? And when he's done, I'm finally going to get the answer back. Okay? That's the idea of what a future is. So I'm going to submit that, and when that's done, I'll get a future from it. So, yeah. What time do I end? 4:45? 20? Okay. So, I'm going to use executors, which is a utility factory, to create thread pools for me. So there are different kinds of thread pools that I can use with Java. Again, I'm not even entering the Guava realm right now. There's a fixed thread pool, which is a fixed number of threads. So I can specify 5, 7, whatever. And if one of the ones one of the threads fails, a new one will be created in its place. And everything is backed up by an unbounded queue. So all these things that you submit to this particular thread pool will be backed up, and so for the next available one, a thread will take it and go ahead and process that. There's a single thread pool, so it's just really a single thread, and there's a line waiting with these particular tasks. And if that fails, a new one will create in its place. CachedThreadPool is a little bit more flexible, so this thread pool you can have any number. So if things are getting really busy, it's kind of like registers at the, well, no. Actually, registers at supermarkets are kind of good like that. So a good grocery store, that's what a CachedThreadPool is. Probably the worst place would be a post office, right? Like they never add anybody. Like there could be a long line and there's only one person at the counter and they never add anybody. So next time you're there, just yell, CachedThreadPool. All right. So, but a CachedThreadPool, again, if things are busy, and you're going to add a few more threads to it. You can have a ScheduledThreadPool and set up a schedule. So after a delay or set up a periodic schedule, you can actually run your tasks. So different thread pools, and I'm going to use this future. And again, it's an asynchronous computation, and I'm going to get an answer in return. Here's the future interface. So again, he's doing this long calculation for me that's going to take some time on another thread. Okay? And I have this future reference. And again, what I'm going to do, the Java way to do it is keep asking, are you done? 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 And then when it's finally done, I call get or get with a timeout. Get will block. Okay? So it's always important that you always ask, is done. So this is the way you actually have to do things. I create an executor service as a cached thread pool, okay? So it's the expandable. I create a callable. Oh, I got call wrong. I'm getting something in return, not putting something in. And I'm going to go to sleep for 5 seconds. I'm going to sneeze, hold on. Okay, no, I'm not. All right, I'm going to go to sleep for 5 seconds, and then when that 5 seconds is up, I'm going to return asynchronous string result. I'm going to submit this task, this callable, onto the executor service, and I'm going to get a future reference in return. I'm going to print out processing 1, and I'm going to call future.get. So since this is going to block, processing 2 is not going to come out yet until I get an answer here. So I shouldn't have called it asynchronous. I should have just called it synchronous because I'm sending off work for you to do, and I'm just waiting around. All right, that's not nice. Now, if I truly wanted it to be asynchronous, what I have to do is this ugly thing here. But it's actually asynchronous. So executor service, asynchronous task, I'm going to fall asleep for a second. Asynchronous is going to return asynchronous string result. I'm going to submit this task onto that executor service, and I'm going to get this future reference. And still I'm going to ask, are you done yet? Are you done yet? Are you done yet? Here it is. So I'm asking, are you done yet? But in the meantime, while I'm continually asking this information, I'm going to do something else. So this is asynchronous. When this finally triggers, then I'll get the answer. This shouldn't wait at all. This should be instantaneous. And so what the end result's going to be is it's going to say processing asynchronously, and then I'm going to have a whole hell of a lot of doing something else. And when this is ready, so after a second, it's going to say, I got the answer, asynchronous string result. Then this is going to trigger, and I'll be able to get the future out of here. It's not too bad, but as you can see, it's going to get kind of messy to finagle these futures here. So what does Guava do for us? Well, it provides us a wrapper called MoreObjects. That's a good wrapper name. If I ever be a rapper, I'm going to be more executors. Actually, my joke, if I were a rapper, I'd call myself Ice Tink. Get it? All right, I'll let you figure that one out. All right, so more executors, and I'm going to decorate this. It's called Listening Decorator, and I'm going to put the thread pool in it. Okay? So what this is going to do for us now is it's going to provide nice callbacks for us, easy readable callbacks for us. So once I once I create a callable, what I can do with that callable now is do the following. So let me see here, I lost myself a bit. So I have an asynchronous task. Here's the callable here. So given this synchronous task, I'm going to feed this into listenable future. Now I remember where I am. Okay, listenable future, this is called listenable future here. And I'm going to submit that asynchronous task here. I'm going to call futures. Remember, that's anything that's a utility. So if I need a utility on futures, I'm going to call futures.addCallback. I'm going to provide the future that I get from here. And now I can create this future callback on the string. If it's successful, I'll do a result. If it's a failure, I'll do a result. So I don't have to do these while loops anymore. I'll just let the lower abstraction do all that for me. Okay? Everything is callback based. Should make your code a little bit cleaner. I will agree that this part's not going to be as clean with the decoration, but you know, it's a lot nicer to handle it with a callback than continually asking, "Are you done yet? Are you done yet? Are you done yet?" Go.
Is that listenable feature actually complete before you get done adding callback?
It could. I think by the time you add the callback, I'm sure it caches it somehow. So once you're creating it, I think it should deliver the answer. That's a great question. I don't know. I mean, I'd have to plug that in and see what would happen. Like if you do something really quick. So like if I put a thread sleep like between those two, that'd be a kind of interesting test. I don't know what would happen. I would assume a good API would just, you know, if it came in already, that it would just be ready to deliver to me by the time I create it. I don't know. That's a great question. All right. So, by the way, take a look at that. This is me using Java 8 functions for this. So as a service, remember callable has one abstract method. So I could just shrink this down by a bit. All right. Ordering, and I have how many minutes? 10 minutes. All right. I think I'll just do ordering and then wrap it up. So, all right, Star Wars fans. Wow, okay, oh, actually healthier numbers. Like, I think probably because the new movie's coming out. Last year when I did that poll, it was just, yeah, I guess. All right. Everyone knows the premise, right? I'm not going to give away anything like if you haven't seen it yet. But you kind of know the characters and know what movies they're from. Okay, so I love Jar Jar Binks. No, I'm just kidding. There's no Jar Jar Binks in this one. All right, so given this Star Wars episode, I have a Star Wars episode with name, number, and year. Of course, I have the getters, toString, and hash codes. All this is set up right now. And I have a comparable. Now, difference between comparable and comparator. Comparable means that you have to implement a compare to. This is called a natural ordering. So what's the natural ordering of a Star Wars character? Well, I made something up. I did comparison of names, and I did a comparison of the year, like how far apart they are. That's going to provide me some int. It's arbitrary, I just made it up. But that's called the natural order. As part of my setup, I'm going to create the movies. The movies are the title of the movie, what the episode order is, and what year that movie came out on. I'll choose Han Solo, Luke Skywalker, Princess Leia, Lando, and Boba Fett. It includes their names and what movie they first appeared in. And here's a comparator. Comparator is something separate, and this is going to compare one episode to another. This is called a year comparator. So it's just going to compare one episode to another. That way I can order the episodes. So given this now, this ordering comes from Guava. And so what I could do is I could say ordering from, and I can provide it the comparator, and I could say which one is the newer one, and it'll be Phantom Menace. Let's see, I heard that was 15 years old now, I think. Phantom Menace, isn't that weird? All right, I digress on that one. All right, here's a character name comparator. So this is going to compare two Star Wars characters, and I'm going to compare that by name. Okay. So I have a Star Wars character year and a Star Wars character name. Let me go back here just so I could reemphasize it. I have a name. Well, let's see, and I have a year comparator. Let's see, I don't know where I lost that one. Okay, so let's say I have two comparators. One Star Wars character year comparator, and the other one is Star Wars character name comparator. Now let's say that I want to sort by year first and then name for the Star Wars characters and what year they first appeared in. Okay. The typical way that I would do it is I would create another comparator that combines the both of them. But the power of this one is the power of the dark side. I just had to do that, sorry. But the power of this one is that I can compound two comparators to one another. Sweet. So this will sort by year, then sort by name. Okay? A lot easier that way. So here's a by length ordering. So I can create an ordering just straight from ordering and compare two strings with one another. So if I do this with Han Solo, Luke Skywalker in the name, I'll get the bigger one. Since I call max, Luke Skywalker string-wise is longer than all the others. So I have my favorite movie. So if I have an explicit ordering that I want to use, this is from my favorite movie, Phantom Menace. No, I'm just kidding, it's the other way around. So it's from my least favorite movie, Phantom Menace, all the way to my favorite one, which is Empire Strikes Back. Okay? It's my own ordering, and there's nothing mathematical about it, it's just my preference to it. And I could say, which one's the better movie, Revenge of the Sith or A New Hope? Obviously A New Hope from that one. Although I did quite enjoy that movie. We could talk about that later. All right. So here's ordering again. Here's the by length ordering. If I want to, I could take this ordering and I could say, shove all the nulls to the end, and I want a sorted copy of this. Okay? So quick and easy ordering with it. I can create a by length ordering right off the bat as well and ask if this is ordered. So is Han Solo, Princess Leia, Luke Skywalker? I did two Luke Skywalkers. That will return true. Is this strictly ordered? This will return false. If they're duplicates, it'll return false. Otherwise, it will return true. So I have different orderings that I can use. I could also query by value. GORM people, for people who use Grails, there's this GORM that you can query by example where you just fill in the elements of your object and then query the database. Same type of thing here. So I wish to query by the Star Wars character by the name Princess Leia, not by any other information. So I could say ordering from the character name comparator and do a binary search based on this key. So you could use an object as an example to do a search on your collection. Okay. Here's a Star Wars character again. Remember, this is natural ordering. So if I wanted to determine the natural ordering from this and do a sort, I can do so by calling ordering.natural, do a sorted copy, and I'll get the sorted copy from it. Okay, I'll probably halt it right there, open it up for any questions. And so if you're not using Guava now, it's a must-have. Take a look at your code, see what you can replace, see what you can make more efficient. It's definitely the library to have for all instances. And with that, I thank you very much for attending.